In this video, the topic for discussion is TCP/IP and OSI data models. So these are called as architectural models, and it is a common frame of reference for internet communication between different hosts. So the first model is TCP/IP model. It is abbreviated as Transmission Control Protocol, Internet Protocol. And this particular reference model, it provides a common frame of reference for developing the protocols used on the internet. It consists of 4 layers, and each layer performs specific functions which help to prepare the data for transmission over the network. The 4 layers of TCP model are application layer, transport layer, internet layer, and network access layer. So the application layer is the topmost layer in the TCP/IP model, and the topmost layer, application layer, receives message from the user, and this message moves from the application layer and goes down till the network access layer. As the data moves from the topmost layer to the bottom layers, header information is added to the messages as it moves through each and every layer. And once the message reaches the bottommost layer, that is the network access layer, the data will be transmitted into the transmission media. And once this transmitted data, it reaches the destination, the message will travel back up through each of the TCP model. The header information that was added to the message will be stripped away as the message moves up through the layer to the destination user. So coming to the purpose of each and every layer. The application layer is the topmost layer of the TCP/IP model, and its main purpose is to provide network services to user applications. The user applications are web browsers and programs. And the different types of network services that are provided to the user applications are mainly HTTP, that is Hypertext Transfer Protocol. The next one is HTML, that is Hypertext Markup Language. Telnet, FTP, that is File Transfer Protocol. SMTP, that is Simple Mail Transport Protocol. And another one is DNS. DNS means Domain Name System. So these are the different protocols that are there in the application layer. Protocol is nothing but it is a set of rules that need to be followed. So what is meant by HTTP? HTTP mainly it deals with the files. A user may want to send files to a destination. So files such as text, graphics, sound and videos are exchanged on the internet. And this HTTP protocol helps to transfer different types of files. Next, HTML. HTML is a page description language, and web designers basically use this particular HTML to design the web browsers. Telnet. Telnet is another application layer protocol, and that is used to access control and troubleshoot remote computers, and also even networking devices also can be uh, can be done. In the same way, FTP, it is nothing but rules that govern in the file transfer. And SMTP means it provides messaging services for email programs. And DNS means domain name system. Its main purpose is to translate domain names to IP addresses. The next one is transport layer protocol. The main purpose of transport layer protocol is to provide end-to-end management of data, and it will divide the data into manageable segments for easily transporting across the network. So end-to-end management of data is done by using two different types of protocol. One is TCP, that is Transmission Control Protocol. Another one is UDP, that is User Datagram Protocol. So TCP basically it is a connection oriented protocol. It facilitates end-to-end communication establishment, error detection and recovery. And it is mainly, TCP is mainly used by applications such as email, web browsers, file transfers and telnet. Coming to UDP, it is often called as a connectionless service or a connectionless protocol. So it does not handle any it does not handle the reliability characteristics, whereas TCP it provides a reliable delivery of data, but in UDP there is no reliability in UDP. And network management applications, network files, file systems and simple file transport are used using the UDP protocol. The next layer, that is internet layer protocol. So its main purpose is to provide connectivity between hosts in the network. So here IP addresses and routing are provided over here in the internet layer protocol, and some of the internet layer protocols are IP, that is Internet Protocol, ICMP, Internet Control Message Protocol, RIP, that is Routing Information Protocol, and ARP, Address Resolution Protocol. So IP protocol, it basically provides source and destination addressing. While coming to the Internet Control Messaging Protocol, it is used for network testing and troubleshooting. It helps to diagnose the errors and ping application that is there. It uses the ICMP echo messages to test if a remote device can be reached. And routing information protocol is basically it operates between the router devices to discover paths between networks. And the last one, the last layer is network access layer protocol. So this protocol, it describes the standards that the hosts use to access the physical media, that is the hardware. The IEEE Ethernet standards and technology are basically used in network access layer protocol, and CSMA bar CD and 10 base T are some of the Ethernet standards that are used in this particular layer. And the next one is OSI model. This OSI model Basically, it is an industry standard framework that is used to divide network communication into 7 distinct layers. So basically, OSI model consists of 7 distinct layers. And let us discuss about each and every layer in detail. Coming to the topmost layer, that is the 7th layer, it is called as application layer. And application layer is responsible for network services to the user applications. So human computer interaction layer, it is also called as human computer interaction layer, where applications can access the network services. And the next one, that is the 6th layer, it's also called as presentation layer. So this presentation layer ensures that data is in a usable format, or you can also say that it will be converted into a standard format, and it is the place where data encryption occurs. So data encryption means to keep your data safe, it will be it will be encrypted. And coming to the next layer, that is the 5th layer, called as session layer. So this session layer mainly it establishes, maintains and terminates the connections between local and remote operations. So it is basically dealing with the establishing, maintaining and termination of sessions. Fourth one, fourth layer is the transport layer, and this transport layer, its main responsibility is to provide reliable transport and flow control across a network. And this data is transmitted using uh, transmission protocols. And the two transmission protocols that can be used are TCP and UDP. And the next one is the network layer. And the network layer is the one uh, that decides which physical path the data will take. So it is basically it is responsible for logical addressing and uh, routing of the data. And the second layer is called the data link layer. So its main purpose is to provide physical addressing and media access procedures. And the first layer is physical layer. So it basically defines all the electrical and physical specifications for the devices. So if you can see over here, these are the 7 layers, and these 7 layers are classified in 3 different ways. That is the application, presentation and session. These 3 are classified as the software or upper layers. And coming to the transport layer, it is called as the heart of the OS. And the last 3 layers, that is network layer, data link layer and physical layer, they are called as the hardware layers. So here if you can see, the entire 7 layers are classified into 3 different parts. So a system that implements protocol behaviors consisting of series of these layers. What are these layers? These layers mean software layer and hardware layer, a combination of software layer and hardware layer. Then you call it as a protocol stack. So protocol stack can be implemented either in hardware or software on a combination of both. So simply protocol layer stack is nothing but it is a combination of hardware and software layers. So here the lower layers are implemented in the hardware, that is network, data link and physical refer to the implementation in the hardware, and the higher layers refer to the implementation in software. So all these three layers are implemented in the software form, and these three layers are implemented in the hardware form. And let us see how the data flows from the sender to the receiver. So whenever a sender wants to perform a data transfer, initially the user resides over here, that is above the application layer. Here is the user. The user will interact with the network services that are provided in the application layer. And once the user, suppose if he wants to send an email, uh, so this will be the email data, right? So this email data, whatever is there, will be sent next to the presentation layer. So information that is flowing from the top three layers, that is these are the top three layers, the information flow, it is considered to be, it is called as data. That is, the user sends a mail, the application layer will add some more information to the user given information, and it forms a data. And next in the presentation also something will be added. After some information is added, it is still called as data. And then even in the session layer, after addition of some information, it is still named as data. So information flow through the top three layers, uh, and it is considered to be data when it gets down to the transport layer. And when it comes to the transport layer, what happens is the data is broken down. The data is broken down into more manageable segments. Those manageable segments are called as protocol data units, that is PDU. So here this is the data that we get from the session layer over here, and in the transport layer another header, that is layer 4 header is being added over here. And this entire thing is now called as a segment, or it is called as a protocol data unit. And next, when this entire segment comes to the network layer, um, another header called layer 3 header will be added, and now this entire unit is called as a packet. It is called as a packet. When this particular data moves down to the data link layer, layer 2 header will be added, and this entire thing is now called as a frame. And once this frame reaches the physical layer, the work of the physical layer is to convert all the data, that is convert the frame in the form of bits. So whenever this particular frame is converted into the form of bits, these bits are ready to be transmitted onto the network media. And here, if you look at the diagram, you can see the flow of data, how the data is being flowed. So this is the device that the user is using. He is sending a mail, and the data is flowing down from the topmost layer to the bottommost layer, where here application it is called as data, presentation it is data, session it is data. Here you call it as PDU, or you call it as a segment. And next you call in the network layer as a packet, you call it as a packet. In the data link layer you call it as a frame, and when it comes to the physical layer, it forms bits, and these bits are ready to be transmitted into the network. So when this is transmitted to the network, when the particular data reaches the destination, again the process of uh, striping away the added information starts from bottom to top, where all the additional information that has been added to the original data will be removed, and finally the email will reach to the destination user. So this is the simple scenario. Thank you.